Hello friends and my dear students, I welcome you all to my channel. This is part 7 video on the chapter of squares and square roots, where I will discuss about how to find the square root of decimal numbers and fractions, and will solve as a demonstrative examples. We will solve some problems from exercise 3F and 3G from the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, if you are visiting my channel for the first time or seeing my video for the first time and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. If you have not seen the part 1 to part 6 videos on this chapter squares and square roots, I strongly suggest that you watch them also to maintain the continuity of your study on the chapter of squares and square roots. So let's start this video. Okay, so I have my quick notes prepared on the left hand side for this video, where I will discuss about finding the square root of decimal numbers and fractions, and on the right hand side I will do the discussion of the concepts and mostly through solving problems. Okay, now first of all, there are two properties or algebraic identities you can say about square roots of two positive numbers x and y. So if x and y are two positive numbers, if x and y are two positive numbers, that is x and y is greater than 0 and both x and y belongs to, they are integers. The z, the capital letter z denotes the collection of integers, and this symbol over here is known as, is called belongs to. This is a convention of sets where it is saying that x and y are integers, and also it is said that x and y are greater than 0 means they are positive integers. If so, then we have the first property says that root over square root of x multiplied by y will be, you can split the x and y apart with their square root, that is will be equal to square root of x multiplied by square root of y. This is the first identity you can use, and the second one is that square root of x by y. So x by y will be a fraction. X by y, since x and y are both positive integers, so x by y will be a fraction. It can be a mixed fraction, it can be a proper fraction or improper fraction. Anyway, so square root of x by y can be written as square root of x divided by square root of y. These two properties we will use for finding the square root of fractions. Okay, now let's discuss how do we find the square root of decimal numbers. Now in the book it has used a long division method to find the square root of decimal numbers. I have I have a little different approach. As you can see from the notes, the PDF of the notes will be the link of the PDF of the notes will be provided in the comment section, so you need not take any screenshot from the notes. How do we find the square root of decimal numbers? First, since we know that the decimal numbers are of the form, let's say 0.216, or we have some whole part and some fraction part. In the 0.216, the fraction part is 0.216 and the whole part is 0. Similarly, we can have 120.0091. In this decimal number, 120 is the whole part and 0.0091 is the fraction part. How do we find the square root of this? Okay, now first let's take the example of this one. Let's say I want to find the square root of 0.216. Okay, so this is one example. No, okay, let's do one thing. I will straight away solve the problems from exercise 3F. Okay, so this was another. These are some examples of decimal numbers whose square root we need to find. Okay. Now let's take an example, one problem from the exercise 3F, and solve it while discussing the steps I have. Step 1, step 2, step 3, step 4. There are 4 steps in my way of finding the square root of decimal numbers. Now in the book, the book it has used directly long division method to solve it with the decimal for finding the square root of decimal numbers, that is numbers having decimal point. If you understand that, that is fine. My method is just that my method is just if you are not comfortable with finding the square root of a number which has a decimal point, then you can find this. My way will allow you to find the square root by finding the square root of a natural number and then doing subdivision by powers of 10. Okay, so this is let's solve exercise 3F. Let's solve. I'm solving exercise 3F. The problem, let's say the problem number 8. We have to find the square root of 0.2916. Okay, so what is the first step in my way of finding the square root of decimal numbers? Express the decimal number as a fraction. So since any decimal number can be converted, can be expressed as a fraction, where fraction means a by b form, where a and b are natural numbers, so b will be powers of 10. We know that when we convert a decimal number to a fraction, the denominator is always a power of 10. So express decimal number as a fraction a by 10 to the power n. Okay, so I'm writing the step so that it will be easy to correlate the notes and the solving. Okay, so the number was the given number is 0.2916. This is equal to, let me quickly check if everything is visible or not. Okay, so this is the given number. I will convert it as a fraction. I know that 0.2916 will be, when I convert it to a fraction, 2916 divided by 10 to the power, the power will be the decimal places of the given number, which is 4. Okay. Now what is step 2? Step 2 says that make the denominator of fraction obtained in step 1 as an even power of 10, multiplying by 10 if required to both numerator and denominator, so that denominator is of the form 10 to the power twice m. That is, it is saying just to convert. So in the step 1, the fraction we got is 2196 divided by 10 to the power 4. Now, if instead of 10 to the power 4 we have some odd powers, then we need to multiply the denominator by 10 and also the numerator by 10. For this problem, we did not do so. It is not required to do so because the denominator is already power 10 to the power 4, which is an even number. Okay, fine. So step 2 is not required for this problem. Step 3. Step 3. What is step 3? Step 3 is asking. So when we are at step 3, find the square root of b. So what is b? After step 2, which was not required for this problem, whatever the numerator was, that is b. So b will be, in our case, 2916, because we did not have to multiply by 10. So the numerator is 2196. So in step 3, we have to find the square root of 2916. Now this square root of 2916 you can find either by the method of prime factorization or long division method. It is up to you. Whichever method is more convenient to you, you will use that. But my recommendation is using long division method, because long division method works well even if the given number is not a perfect square. If the given number the number whose square root you are trying to find, if it is not a perfect square, then long division method is a preferred way. And if you can see, if you know that that number has to be a perfect square, then you can do so by the prime factorization method. So I am using long division method. So I have to find the square root of 2916. I am using the long division method. Now while I am finding the square root using the long division method, I will not discuss or explain each step of the long division method. For that, I will request you to watch my video where I discussed about finding square root of using long division method. Okay, so first we need to create the periods, which is a pair of digits starting from the right hand side. So we have 16, 29 and 16. Now we will start from the leftmost period, which is 29, and see what can be, and we need to find the divisor, so that single digit divisor, so that its square will be less than equals to 29. So clearly we can see it will be 5. So 5, the quotient is 5. We have 25. We will subtract 25 from 29 and we get 4, and then we bring down the next period, that is 16, and the 416 becomes the new dividend, and the new partial divisor will be whatever the current quotient is, which is 5 multiplied by 2, so 10. Now we have to find find the digit x such that whatever this 3-digit number is, 10x multiplied by that digit x should be less than equal to 416. Now this implies, what can x be? This implies x is equal to, can it be 3, can it be 4? Yes, it is 4 indeed. It is 4. So 104, as we can see, 104 multiplied by 4 is 16. 4. Okay, so the x will be 4. So I am rubbing x, I am putting 4, and the 4 will also get appended to the quotient 54, and we get 104 multiplied by 4 is 416, and the remainder is 0, and there is no more periods. So the long division method is complete, and we know that the quotient will be the square root of the given number that we are finding using the long division method. Therefore we get square root of 2916 is equal to 54. Now what is step 4? As per my notes, step 4 is the last step where we find the final square root. So step 4 is saying that the required square root, can you see my notes? Okay, the required square root of the number will be c, where c was the square root that you found in step 3, c by 10 to the power m. 10 to the power m, remember, after step 2 the denominator was an even power of 10. If you express that even power of 10 as 10 to the power twice m, then the final square root will be c by 10 to the power m. 10 to the power m. You just divide c by a power of 10, where the power will be the half the power of the denominator in step 2. So we know that in our case denominator is 10 to the power 4. So finally we will divide by 10 to the power 2. Okay. So step 4, we say that square root of the given number, that is 0.2916, will be equal to 54 divided by 10 to the power square. Why square? Because after expressing the number in the fraction form, the denominator was 10 to the power 4 and the power was already even. So it was 4. So in step 4 we have to divide by 10 to the power 10 square, the half of 4. Whatever the power was, that divided by 2, 10 square, and we know this is 54 divided by 100, and this we know is 0.54. So this is the value of square root of the given number 0.2916. Okay. Let's find another. I will not do all the problems because it will be redundant. If I can solve 2 or 3 problems, I think it will be clear to you. Okay. Let's do problem number exercise, still from exercise 3F. Let's do problem number, let's say problem number 6. We have to find the square root of 10.0 10.0489. Okay, so step 1 is that I will convert the given number as in the fraction form. So I know 10.0489 in the fraction form will be 100,489 divided by 10 to the power. The power will be the decimal places of the given number, which is 4, which is again 4. Okay. Now step 2 will not be required because we see the denominator is already a even power of 10. So we will now go to step 3, which is finding the square root of the numerator, that is 100,489, and using the long division method. So we have 100,489. We create the periods, that is pairs of digits from the right hand side. We have 89, 04 and 10. And we start the division from the leftmost period, that is 10. So obviously the divisor will be 3. 3 into 3, we have 9. Subtract 9 from the leftmost period, we get 1. We bring down the next period, that is 04. 104 becomes the new dividend, and then the new divisor, partial divisor, will be 2 multiplied by the quotient, ignoring the decimal point in the quotient, even though we are not dealing with any decimal point in the quotient. So 3 into 2 is 6. Now I have to consider digit x, some digit after c, after x, after 6, such that this 2-digit number 6x multiplied by the digit x has to be less than equals to 104. So this clearly says we can see that x will be 1. So x will be 1. Okay, I am putting x equals to 1. 1 also need to be appended to the quotient, 31. Now 61 into 1 is 61. That need to be subtracted from the current dividend. So we have 104 minus 61 is how much? I guess 42. No. So 3 and 43. Okay. Now we bring down the next period, that is 89, and the new dividend becomes 4389. 4389. Okay. The new dividend becomes 4389, and the new partial divisor will be 2 times the current quotient. So it is 60. 31 into 2 is 62. Now again we have to consider the digit after 2, 62x, such that this 3-digit number 62x multiplied by x should be less than equal to 4389. So this implies, can x be 3? Can x be 3? No, it should be greater than 3. Can x be 7? Let's try with x as 7. So 627 multiplied by 7 is 49, 70, 14, 18. Okay, so it is perfectly matching, 4389. So this implies x is equals to 7. So x will be 7. I am rubbing x and putting 7 over here. 7 will also get appended to the current quotient, 317, and we have 627 multiplied by 7 is 4389, and so there is no remainder is 0, and there are no periods left. So therefore square root of 100,489 is equal to 317. Now the final step to find the square root will be c. The square root will be c, which we have found in step 3 as 317, c by 10 to the power m. Now what 10 to the power m? we have 10 to the power twice m equals to 10 to the power 4. So 10 to the power m will be 10 square. So the final square root will be 317 divided by 10 square. Why square? In the first step, the denominator we have found to be 10 to the power 4. It has to be an even. If instead of 10 to the power 4, it was 10 to the power 5, we would have multiplied the denominator by 10 and also the numerator by 10. Okay. So this is 317 divided by 100, and we know this is equal to 3.17. So this is the 3.17 is the square root of the given number, which is 10.0489. Okay. Let's try to find okay, let's do some example which is not from the book, but let's say we have to find the square root of example. Okay, so find the square root of, let's say 7.125. So we have to, the decimal number given is 7.125, and how do we find the square root? Okay, so step 1. Now obviously when you will solve it, you will not write it, solve it using step 1, step 2, step 3, that you will automatically do them. You did not write the step 1, step 2, step 3. This is just for your understanding. So we are given the number is 7.125. We have to convert it this in fraction form. We have 7.125 divided by 10 to the power 3, because 3 is the decimal places of the given number. So now we see that the denominator is 10 to the power 3. Power 3 is an odd number. We have to make it even. So we will just multiply both the numerator and the denominator by 10. We can do this. Now we have the number as 71250 divided by 10 to the power 4. So now we have the denominator as even power of 10, that is 10 to the power 4. Okay. Now, sorry, this was actually this thing should be part of step 2. So 7.125 is 7.125 divided by 10 to the power 3. Now in step 2, it says that we have to make the denominator, we have to find the equivalent form of this fraction so that the denominator is an even power of 10. So now we will have that 7.125 divided by 10 to the power 3 is equal to, we can say, this. We multiplied both sides, both the numerator and the denominator with 10, so that the denominator is an even power of 10, and we got 71250 by divided by 10 to the power 4. Okay. Now in step 3, we have to find the square root of the numerator, that is 71250. We use the long division method. 71250. The periods are 50, 1, 2 and 7. Okay. Now obviously the first divisor will be 2. We have 4, remainder 3, and then we bring down the next period, that is 1, 2. 312 becomes the current dividend. The next partial divisor will be 2 into 2, that is 4. Now we have to find the digit x after 4, such that this 2-digit number 4x multiplied by x should be less than equal to 312, and that should be 728. No, it will be 6. This implies x will be equal to 6. X cannot be 7 because 47 multiplied by 7, I guess, is exceeding 312. So 46 multiplied by 6 is 36 and 27, 276. So x will be 6. I'm rubbing x and putting 6 over there, and 6 will be also appended to the question, and 46 multiplied by 6 is 276. We take the remainder, we find the remainder, which will be 6, 8, 36. We bring down the next period, that is 50. The current dividend becomes 3650. The next partial divisor will be 26, the current question, which is 26 multiplied by 2, that is 52. Now again we have to find the digit x such that the 3-digit number 52x multiplied by x will be less than equal to 3650. This implies x will be, can x be 7, 49, so you put 14, 18. No, I think x will be 6. X will be 6 because 5 to 7, x cannot be 7. So if we do 7, then we are having 527 multiplied by 7 as 49, 14, 18, 3689, which is exceeding. So this implies x has to be 6. Okay. So now what is 5 to 6 multiplied by 6? 36, 15, 31. Okay. So x will be 6. We are rubbing x and putting it there 6. 6 will also get appended to the question, and 5 to 6 multiplied by 6 is 3156. We find the remainder. This will be 4, 6 and 9, 494, and 494, and there is no okay. Now the remainder is not 0. The remainder is not if the remainder is not 0, actually there will be decimal point in the square root, but let's say now if you want to find the, so the remainder is 0 and all the periods are exhausted. So now we have to put a decimal point. We have to put a decimal point in the given main number, that is 71250. We will put a decimal point and we will add, I'm writing in top, we will add, let's say, 2 periods of zeros, and there will also be a decimal point in the question. Now if we continue with the long division, what will happen? We have the remainder 4940. I will bring the next period, that is 00, over here, and the next divisor, partial divisor, will be the current quotient ignoring the decimal point multiplied by 2. So that is 6 to the 12, 13, 732, and so now we have to find x such that the digit x such that this 4-digit number 732x multiplied by x will be less than equal to 49400. So this will imply, what will x be? X can x be no, x cannot be. This implies x cannot be 7. I guess x will be 6. So let's see what is 7326 multiplied by 6. How much is this? 36, 15, 19, 43956. 43956. 49. Okay, so x will be 6. So over here x will be 6. X is 6. We append 6 with the question, and 7326 multiplied by 6 is 4, 3, 9, 5, 6. Now there will be some remainder. Okay, let's find the remainder. 4, 10, 6, 4, 4, and then 5. So if we want to stop the long division over here, then we have found the square root up to 1 decimal places. So we get square root of 71250 as equal to 266.6. Let me quickly check in the calculator whether this is more or less approximately correct or not. So 71250 square root is 266.92. So 266.92, but I got 266.6. Anyway, there is some mistake in the decimal point. I'm not really focusing in that. So the idea was to show what if the given number, when you convert it to the fraction, if the fraction in the denominator, the 10 is or the power of 10 is odd, then what will you do? You just multiply both the numerator and the denominator with 10, so that the denominator becomes an even power of 10. So in this problem we got 10 to the power 4. Now let's say even though 266.6 is the wrong calculation, it will be 266.9. Anyway, assuming square root of 71250 is 266.6, so step 4 now will be the final square root will be the square root that we obtained in step 3, that is 266.6 divided by the denominator we had in step 1, or rather after step 2 was 10 to the power 4. So we just divide it by 10 to the power square. So this is equal to 266.6 divided by 100. This is equal to 2.666. 2.666 is the square root of 7.125. I hope you got the idea how we are finding the square root of a decimal number using the long division method by converting it following the 4 steps that is in my notes. In the notes I have also solved a very simple example from the book. Okay, now finding the square root of a fraction. Let's discuss how do we find the square root of a fraction. So let's say the given fraction is p by q, where of course p and q are natural numbers. How do we find? Now we have to find it case by case. If p and q, if both the numerator and the denominator of the given fraction are both perfect squares, then we simply write square root of p by q will be equal to square root of p divided by square root of q, and we know that we can find square root of p and square root of q. So that is case number 1, when the given fraction, both the numerators and the denominators are already perfect squares. If they are small numbers, you can easily figure it out whether it is a perfect square or not. Now if they are not perfect squares, then you would like to simplify the given fraction p by q to a much more simpler form, and let's say a and b, where you will find that a and b are both perfect squares. So now it will be square root of p by q will be equal to square root of a by b, where a by b is the simplified version of the p by q, and we know that a and b are perfect squares. And so square root of a by b will be equal to square root of a divided by square root of b. Okay. Now let's solve some problem from the exercise 3G, which is based on findings from the exercise book, from the book of author RS Aggarwal, exercise 3G, which is based on finding square root of fractions. Okay, so let's solve There are 10 problems. Let me try to solve all of them to give you a better clarity. Okay, so the first one is square root of 16 by 81, and you clearly know that the fraction 16 by 81, both the numerator and the denominator are perfect squares. So we can say this is equal to the square root of the numerator divided by the square root of the denominator, and we know the square root of 16 is 4, and the square root of 81 is 9. So 4 by 9 is the answer. Okay, let's do problem number 2. Okay, let's do problem number 2, which is square root of 64 divided by, the fraction given is 64 divided by 225. Now we also know that 64 is a perfect square and 225 is also a perfect square. So this will be equal to square root of the numerator divided by the square root of the denominator. Square root of 64 is 8 and square root of 225 is 15. I might do some calculation mistake. Please don't focus in that. I hope square root of 225 is 15. I will check it once again. 75 and 15, and yes, it is 225. So the answer is 8 by 15. Okay. Problem number 3. We have to find the square root of 121. The fraction is 121 divided by 256. Now we know that numerator 121 is a perfect square. Its square root is 11. What about 256? 256. 256. Now sometimes for small numbers, to check whether it's a perfect square or not, I use prime factorization method. So let's divide. Let's say I will not divide by 8. I will divide by 4, and this is 664. Okay, so this will be a perfect square. Okay, so now this will be 121, we know is a perfect square, and also I can see 256 is also a perfect square. So this will be square root of 121 divided by square root of 256. This is equal to 11 by square root of 256 will be, so 256 is nothing but 256 is equal to 4 multiplied by 64. This is equal to 2 square multiplied by 8 square. This is equal to 2 multiplied by 8 square. So therefore root over 256 will be 2 into 8, that is 16. 11 by 16. Okay, let's do problem number 4. The given fraction is 625 divided by 729. I'm not sure about 729. 625, I think the square root is 25 is a perfect square. What about 729? 729. 9, it is dividing by 9, so 81. Oh, okay, fine. So 729 I can see is 9 multiplied by 81. This is equal to 3 square multiplied by 9 square. This is equal to 3 multiplied by 9 whole square. So definitely we can see both are perfect squares. So this will be square root of 625 divided by square root of 729. Square root of 625 is 25, I know, and the square root of 729 will be 3 into 9, that is 27. Okay, let's do problem number 5. It is okay, so the given fraction is given in terms of mixed fraction 3 and 13 by 36. For this kind of problem, you have to first convert the mixed fraction into a improper fraction. So this is 3 and 13 by 36 will be 36 into 3 plus 13 divided by 36. How much is this one? This is 36 into 3 is 108 plus 13 divided by 36. This is equal to 121. Okay, so 121 divided by 36, and we know that 121 by 36, both the numerator and the denominator are perfect squares. So this will be equal to square root of the numerator divided by square root of the denominator, and this is equal to 11 by 6. 11 by 6. Let's do problem number 6. The given fraction is again improper fraction, 4 and 73 by 324. We have to find this. So this is equal to, let's first convert the mixed fraction to a improper fraction. So this becomes 324 multiplied by 4 plus 73 divided by 324. So this is equal to 324 multiplied by 4 is 16, 9, 12 plus 73 divided by 324. I am not sure about what is 324. Okay, so this becomes 9 and 16 and 3 and 1 divided by 324. Now, I have no idea about 1369 and 324. We have to check. Let's find out if 324, okay, let's see what is 324. If I do divide by 4, I have 81. Okay, fine. So 324 is equal to 4 multiplied by 81, which is equal to 2 square multiplied by 9 square, which is equal to 2 multiplied by 9 whole square. So 324 is a perfect square. What about 1369? 1369. Okay. So will it divide by, okay, I can see it is dividing by, no, it is not dividing by 3, no, 13, 1, 0, no, 9, 9, 4, no, 7, 1369, okay, 9, 16, 3, 7, 6, 8, 9, 4, 46, 45, 81, 3, it is not dividing by 3, 4, 12, 15, 9. Let me check if I did the calculation correctly or not. 4 and 73 by 324. So this is 324 multiplied by 4 plus 73. That is 16. 324 multiplied by 4 is 16, 9, 12, 1296. Okay, plus 73, which is 9, 16, 3, 1, 3, 6, 9. Okay. Now, whose square root? We have 1369. The ending digit is 9. So if it is a perfect square, the number whose square is this number, that number should end with 3 or 7. That number should end with 3 or 7. So I'm stuck at this point. I cannot find the square root of 1369. So let's do it by the long division method. I hope this is a perfect square, but I can't seem to figure it out. So I'm using the long division method. So I have this, and I know this will be 3, 3, 9. I know this is 4, 69, 6, and this will be 3. No, no. Uh, 6, 49, 7. Oh, I think this is 7. I think this is 7. 49, yes. So it is 37. Okay. So we see that this is equal to now 1369, the square root of 1369, but the long division method I found to be 37. Now the square root of 1369 divided by 324 is equal to square root of 1369 divided by square root of 324. Square root of 1369 I found out to be 37, and square root of 324 will be 2 multiplied by 9. So this is 37 by 18. This is an improper fraction. You can convert it to a proper fraction as 2 and 1 by 18. So this is the square root. Okay, let's do quickly. Let's do all of them quickly. I don't know how quickly I am doing. So the given fraction is again a mixed fraction, 3 and 33 by 289. These are really big numbers. Okay, so this is equal to, if I convert the given mixed fraction as improper fraction, I get 289 multiplied by 3 plus 33 divided by 289. So this is equal to 289 multiplied by 3 is 27, and 24, 26, 8 plus 33 divided by 289, and this is equal to 10. It's 10, and this is 10, and this is 9 divided by 289. Now 289, so we know that 900 is a perfect square, and also 289 is a perfect square. So we have the value as square root of the numerator divided by square root of the denominator, and square root of 900 is 30, and square root of 289 is 17. So this is equal to 30 by 17, which is an improper fraction. If you can convert it to a mixed fraction, this becomes 1 and 13 by 17. This is the answer. Let's do 8. This is also okay. This is square root of 80. It is in a different form, and square root of 405. Now we can clearly see most probably 405 is not a perfect square, and also it is not a perfect square. But as we have seen for at the very beginning in the notes, you can see that square root of x by y is equal to square root of x divided by square root of y, where x and y are positive numbers, for positive numbers. So we are given the form square root of 80 by square root of 405. So we can write it as square root of 80 by 405. Maybe 80 by 405 can be converted into a simpler form, so that the numerator and the denominator both will be perfect squares. Okay. Now, how much is 80 by 405? If I cancel by 5, this is 16, and this is 81. Okay, so we got this is as 16 by 81, and now we see 16 by 81, both the numerator and the denominator are perfect squares. So we can write it again as root over 16 divided by root over 81. This is equal to 4 by 9. 4 by 9. Okay. Let's do problem number 9. It is given square root of 1183 divided by square root of 2023. Now we know that we have studied at the very beginning when we were discussing about the properties of square numbers that any square number cannot end with the digits 2, 3, 7 and 8. So in this example we see the square root of 1183. 1183 is not a cannot be a perfect square. Also 2023 cannot be a perfect square. So we have to try out to express this as 1183 to see maybe there will be some cancellation and we will get a good P by Q form where P and Q could be perfect squares. Okay, now how do we cancel out 1183? How do we simplify 1183 and 2023? Mm, 7. Now there is a way of finding the HCF of two numbers. What was that? What was that? If I remember to find the common HCF, the HCF between two numbers 1183, this is the smaller number. If we divide by 2023, it will not divide by 2, it will be 1. So 1183 and the remainder is 0 and 4 840 and then possibly this will be the divisor and 1183 will be the dividend and we will have 1. We will have 1. So 840. This is 3. This is 4, and this is 3. So now 3, 4, 3 will divide. 840 will become the dividend, and the remainder will be the divisor, and we have 2. So 686, and we have the remainder 4, 10, 5 and 1, and then we again divide 343 with 154 and we get 2, 8, 10, 3. The remainder is 5, 35, 35, 35. We will divide 154. Will be 4. So 20, 140, 14, and we divide by 35, and we divide by 2, 28, 7. Okay, so 7 is the, so it is dividing by 7. So how come I cannot figure it out? Anyway, so if I divide by 7, this becomes 1183 divided by 7. This is 1, 48, 6, 6. What? 1, 4, 48, 42, 63. 169, and you divide by 7, 2023, it is 7, 2, 14, and 6, 62, 8, 56, 63, 9. So 169 by 289, 169 by 289. Okay, so this is equal to it's coming 169 divided by 289, and we know that both the numerator and denominator are perfect squares. We can write it as square root of 169 divided by square root of 289, which is equal to square root of 169 is 13 and square root of 289 is 17. So 13 by 17 is the answer. Okay, let's do problem number 10. The last problem of exercise 3G, which is square root of 98 multiplied by square root of 162. Now we can see that both the numbers inside the square root are ending with 2 and 8, and we know that any number ending with 2, 3, 7, 8, they cannot be a perfect square. So 98 and 162 are not perfect square. So let's try to merge them together and write it as square root of 98 multiplied by 162. Now instead of doing the product, finding the product of 98 and 162 and then finding the square root, it is often convenient, very very convenient, if you can express the numbers as their factors or prime factors. So 98 I know is 49 multiplied by 2, and this 162 I can see it is 81 multiplied by 2. So this becomes 49 multiplied by 81 multiplied by 2 square. So this is equal to square root of 49 is 7 square multiplied by 81 is 9 square multiplied by 2 square. So this is equal to square root of 7 multiplied by 9 multiplied by 2 whole square. So this we know is equal to 7 multiplied by 9 multiplied by 2. This is equal to 63 multiplied by 2. This is equal to 126. 126 is the answer. Okay, so this brings to an end of the topic of finding the square root of decimal numbers, fractions, and few properties of finding some algebraic identities of finding this regarding the square root of fractions, and where square root of the positive numbers x and y, where root over x into y, where x and y are positive numbers, is equal to root x into root y, and square root of x by y is equal to root x by root y. So I hope this video was beneficial. You got an idea of how to find the square root of decimals using the long division method and the steps, the 4 steps that I have mentioned in the notes, and also how to find the square root of a fraction. So if this video was beneficial, then please like it, share it with your friends, and also once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve the objective questions that will be 3H. I hope the objective questions is 3H, exercise 3H, and then we will there is a test paper which is test paper 3. We will solve the test paper 3. That will bring an end in discussing the chapter of squares and square roots from the book author RS Aggarwal, and then I will prepare 2 sample test paper as I always do for any chapter. Sample test paper 1 and sample test paper 2, and also look out for my 10 good problems from the playlist CBSE 8 Hot, where I come up with 10 good problems from every chapter every now and then. Also look out for my videos in that playlist. So thanks for watching, and until the next video, take care and bye.